Hi, my name is Neil, and today I'm going to be talking about CNNs, or convolutional neural networks. So, let's get to it. A CNN is a convolutional neural network. So the C stands for convolutional. So it's a neural network, but it's convolutional. So what is convolution? I'll show you some different kinds of convolution. So the first one is edge detection. So edge detection detects the edge, and it's convolution because you have this notion of a kernel, which is this mini matrix. But then you put that on top of your larger matrix. So both of these are matrices. So then you move this around, you keep on moving this around, and how much ever you move it to the side, whatever number that is called your stride. And then, whenever you do edge detection and you do it like this, then whatever thingy that you get here, like for each one of these kernels, it would actually make this thing smaller. So if you want it to be the same size, then you can do this thing called padding, where you basically go outside of the limits so that it'll stay the same size. So now let's get to edge detection. So what edge detection does, edge detection, it works on these different kernels. The one that I'll be using most looks like this. So 0, 1, 0, 1, 0, 1, 0, 1, 1. So there are many other different kinds of matrices, and they kind of do edge detection, but they're a bit different. Like they kind of function differently and stuff, so you just gotta pick. So we'll be using this one, and basically what you do when you put the matrix down, you have a value in each of these spots. You have each of these spots, in this case it's 3 by 3, but it doesn't have to be. They have some numbers, so each of these have some value in the matrix, and then they have a different value in your edge detection kernel, right? So then you do dot product with the matrix that you pull out of the bigger matrix and this kernel. So then you do this one times this one times this one times this, and then it stays there. So and then kind of stays there, right? So you do the dot product with all of these here, and you keep on moving it, and then you get edge detection. So you do the dot product, and if you do edge detection, so I have my kernel here, and I have my 28 by 28 matrix. It's not going to be this fine, right, in your 28 by 28 matrix. So all of this is shaded in. So if you put this through your edge detection, then what you get is you get this, and if you're using the 3 by 3 kernel and your stride is 1 and you have no padding, which is what's kind of default, you'll get a 27 by 27. Because when you move it, there's this, and it gets 27 by 27. And then what you get is you get kind of the same 2 it's kind of the same as drawing this 2. Drawing your 2, right? You've got your 2, and then it's shaded in, right? And then all you just erase everything inside, and what you get is the outside of it. Now this is useful because when you're doing numeral detection or a lot of other things, you pretty much only need the edges to do it. Think about it. You see that tree outside. Then if you have the outline of the leaves, outline of everything, it still looks like a tree. You could do this for pretty much everything and you'll still be able to recognize it. Sometimes the edge detection might be bad, but if it's good. So now, let's look at another one that we'll be using in the CNN. In this one, in the edge detection, you had different size kernels too. But in this one, you don't really have the different things inside of it. Like, it's not like, it doesn't have something inside of it. It doesn't have values, but you can kind of change the size. So it's called pooling. And there's different kinds of them, max pool and average pool. So there's max, average. That kind of look a little bit different, but they kind of do the same thing. So what you do is you take your matrix, you can define it this size or this size. It doesn't really matter. But what you do is you take your matrix over here, right? Then you put your kernel. Now, you have your whole kernel, and it doesn't have any value. It's just a kernel, and it's the size that you're taking out of that bigger matrix. Now, let's say you have 1, 0, 0.1, and 0.2. So, for max pool, you take the max of all of these, which is 1, and put it into the smaller matrix, which, if you have one stride and no padding, if you have like one stride and no padding, if you have normal default, and this is 28 by 28, it will get you to 14 by 14. Just makes it smaller, but it kind of keeps the image inside. It's like you take a 4K video, but you're looking at it on a phone. You would kind of do this pooling, and you could still see it, but it would be in a smaller screen. So and this is max pool would be in this spot corresponding with this. It would be 1. That's for max pool. But average pool, you would take the average. So these are 2 kinds of convolution that we will use in our CNN. So what CNN basically is, we go to the main idea is you have this. Put it through a bunch of processing layers. You process it a bunch, and then you put it into your 10